All right, Richard Halverson here. This is ITS388AL, and today I'd like to cover the slides in Chapter 5. I'll try to keep it short, and then we will dive right into some of the coding, which is going to be kind of fun this time. So I'm sharing my screen, and let me pull up the slides. Here they are. And so this time we're going to be talking about procedures and how to call procedures and so on. So let me get this a little bit better here. All right, that's fine. Okay, so in this chapter, we're going to talk about stack operations, defining and using procedures and linking to the external library, to this Irvine 32 library, which is kind of interesting. And then we'll briefly cover the 64-bit assembly language programming, but we're not going to really do any exercises there. It's just an extension. 64-bit programming is just an extension of 32-bit, and if you understand that, if you understand 32, then 64 is not a very large leap forward. So stack operations, we're going to talk about the runtime stack, what that means, push operations, pop operations, and the instructions that go along with that, and how to use them. And we'll do this example here of reversing a string, and then look at some related instructions. So if we think about a stack is, imagine a stack of plates, and you know, let's say you start at the bottom here, first plate, and then you stack them up to here, and plates are only added to the top, and plates are only removed from the top. This is called a last in, first out structure, which you're probably familiar with. The runtime stack is it's managed by the CPU, and it uses two registers. It uses the stack segment. You recall there's 4 segments: data segment, code segment, and there's a stack segment. And then there's this stack pointer, or when we're in the 32-bit world, it's the extended stack pointer. And so, so this is a picture here of what a stack looks like. And we notice that, you know, its addresses go up. This is the highest address. The stack pointer right now is pointing to 1000. It's the stack, the contents of ESP is 00001000. So it's pointing to this address here, and there's a value in here. It's a 6. And when we want to push something onto the stack grows down. Okay, so 1000 hex is higher up than FFC hex, which is higher up than FF8 hex. So as we add data to the stack grows downward. And so here, this is what it would look like after we push 2 more integers. The 6 is still there, the A5 that we pushed in this slide here, and then we've pushed 2 more. And so the stack pointer, you notice the ESP always points to the last entry. So when you're adding something onto the stack, you need to increment the stack pointer first, and then you can store the value where the stack pointer is pointing. So a pop operation does just the opposite. It removes the value, the data item or the datum where this extended stack pointer is pointing. It removes that out and probably pops it into the accumulator or to the EAX register or wherever. And then the stack pointer is incremented to point to the value that was entered just before the value that you just popped out. These are the push and pop instructions. You can push adds to the stack, pop removes from the stack. You can push either a 16-bit register or a 16-bit memory data item from memory. So you can grab out a memory, push that in the stack. 16 bits, you can do 32 bits, which is what we normally do. And then you can also push an immediate 32-bit value. So that's in the code if you want to push a constant into the stack. For popping will pop out the top value of the stack and place that value into a register or a memory location. That's a 16-bit pop. A 32-bit pop will pop into an E register, EAX, EBX, whatever, or into a 32-bit memory location. So here's how you might use push and pop to save and restore registers when they contain important values. So, you may want to do some stuff, or you may want to, here we're calling a program, and this subroutine here, we're calling this subroutine called dump dump the memory, I suppose, display it out. And this dump mem subroutine has 3 arguments. We have an argument that we stick into the ESI register, an argument, this is where it starts. The number of words here is going to be put in the ECX register. We're going to probably have a counter or something. And then EBX is, I'm not sure what that's going to be used for, but that's a, well, this is the, this is going to tell us what size the operands are, whether they're 16 or 32, and presumably that we'll be using that to increment what ESI, either increment or decrement ESI. And so since we're going to use up these registers, we want to save the old values. So here we do, we push whatever is in ESI onto the stack, we push whatever in ECX onto the stack, we push whatever in EBX onto the stack, we do our thing. When we're all done, we're going to pop the values back out into those registers so they are just as they were before we started this whole thing. And you notice we have to pop them out in reverse order. So the last one we pushed in was EBX, so that's the first one we pop out. Then we pop out the next one, which was this one, and then we pop out the last value, which was the first value that was pushed. Here's an example of when creating a nested loop. We have a counter. We use the ECX register to count how many iterations our loop should execute. And we only have one ECX register, but we have a loop inside of a loop. So what we can do is we can start with the outer loop here, and we're going to do that 100 times. So let's push that into ECX. And then we're going to go inside here and we're going to do this inner loop here, this loop right here, from here to here. And so what we want to do is, once we get here, we're going to push ECX into the stack to save it. And then we're going to put how many times we want the inner loop to execute. And then this thing goes ahead and executes this L2, loop L2. It's going to loop 20 times. Each time it does a loop, it's going to decrement the ECX counter. And when it gets down to 0, it's going to drop out of the loop. And what is it going to do? It's going to pop back the old value of ECX, which was pushed here. And then the outer loop execution, the loop instruction is executed after that. And so it decrements this ECX counter if it's 0. If it's not 0, it jumps back up to here and does the whole thing over again. The first thing it does is it pushes ECX to save it. And it's going to loop here 20 times, and then it pops back out again one more time. So this outer loop is going to go from 100 down to 0. But each time, with each pass, we're going to do this inner loop, 20 times. And so that's how you can have nested loops using one single ECX register. For the counting, we just need to push the ECX register when we want to use it for something else. And then when we're done, we pop it back out again and continue on our way. Here's an example of reversing a string. Use a loop with an extent. We're going to use a loop with with index addressing. We're going to push each character onto the stack. So we're going to loop and we're going to push each character onto the stack. Then when we're all done, we're going to pop the stack, and we're going to pop each character back out again, and we'll put it back in the same order that we pushed them, and then what will end up happening is the string will appear in reverse in the reverse order. So let's look at the source code here. Let me grab the source code. So first we'll go to La Lima, and let's start by downloading. Let's go to resources, and if we click on this Irvine folder right here, we can click down and we actually can go to chapter 5 and 32-bit. And let's see, this here is the reverse string .asm file. So I think I'm going to download that. Maybe I'll save it on my desktop. And I think I'd also like to take a look at this message box here. I'm going to use that to display out. And to get started with our code, let's go and download the Project 32 Visual Studio zip. Let's put that on the desktop. And all of the library functions are in this irvine.zip, which is actually the same as what's in here, but we need a zip version of it. So I'm going to put that on the desktop. And so that's, let's see, let me go back to the desktop. Can I go to the desktop from here? Let me exit full screen, and let me go down here. So over here. Okay, so we've got Irvine 32 here. So let's unzip that. That takes a little while. And in the meantime, can we unzip this? I suppose we can do that at the same time. Oh, good. Okay. So that's the project here. Let's take a look at this rev string.asm so we can see what that looks like. No, I have okay, I've got an editor here, and we see that it's basically just we've got a string here, and this will compute to the size of the string because of where the $sign is and so on. Okay, that's opened up. And then this is the main procedure, and so what it does is it loads this into the counter. That's how many characters it's going to move. It's going to use this as an index to the counter, you see, starting at 0. And so it's going to move. This is a loop from here to here. It's going to loop and read each character at a time, putting it in EAX, and then pushing it into the stack, and then incrementing to go to the next one. When it's done pushing all the characters, all these characters into the stack, then it starts another loop, same size, starting at the beginning again, right here, and it pops the characters out of the stack and stores them back into the array. And so the last one that was pushed was N here, and so that's going to be popped and stored first, and that's going to be stored here at the beginning. So N will be stored here, this L will be stored here, the O will be stored where the R is, the C will be stored where the A is, and so on. So that's how that'll work. Let's, in this project here, I'm going to use this project as a startup project. Let's start it up. All right, let's see. We've got, this is the way my thing is set up. I've got a Toolbox Server Explorer over here. This is my add to some, let's open this up. And you recall, this is what we start with. I'm gonna change it to the rev string. So let me just, first of all, I'm gonna rename this. I'm gonna do it kind of this way. Reverse, just REVSTR, reverse string. Maybe I'll do this. REVSTR. Okay, so that's what it's going to be called. And I'm going to go over to this reverse string here and open this up, which was right here. And I'm going to copy this. Copy. And I'm going to pop it right into here. Paste. And okay, so here, now the program is in here. It's called rev string. I'm going to build it, and we'll get an error. And you can see we've got this error because I couldn't find the library that is right here. Not there, but right here. So we need to tell the assembler, the linker, I guess, where that library is, and it's right here. So I'm going to copy this, and I'm going to go back to my Visual Studio project, go project properties, and I'm going to click on linker over here. I think this is a better place to do it. You can do it here, right there, I guess, right there. Put it right there, semicolon, and put it there. Or I think a better place is to put it here because this is where it was expected, which would be on your C drive in a directory called Irvine. You don't have to put it there. So I'm going to paste, and this is where mine's is, and I click OK, and then this should build. And we see it does. So let's see. So let's run this and see what it looks like. I'm going to put a breakpoint. I'll put a breakpoint right here. So this will have been pushed into the stack already, because that happens right here. It pushes it into the stack. Then there's going to be a breakpoint here, and then when it's done, let's do a breakpoint. Let's do a breakpoint like right here or something, just before it returns. Okay, so let's build this, and I'm going to put another breakpoint just before we start out here. Let's see. I'm going to put a breakpoint. Oh well, right here like this. All right, so let's build. Let's see. We don't need to build it again. Let's start the debugging. Start debugging, and we're stopped. Oh, we're stopped right here, and we can look at the. Let's see. Let's look at some stuff. Let's look at some registers. Let's do debug Windows. Let's look at some registers. Okay, so
Oh, and let's look at some memory. Let's do debug Windows. Let's look at some memory. Let's look at memory 1. And oh, here's where 4040. Let's see if the data. Okay, let's look at the registers and the data register here. All right, so here we're just starting out, and this is what the memory looks like. It's got Abraham Lincoln in the memory starting at here, 44,000, which is probably like right here, right where the data segment starts. And we're sitting right here. We've moved the name size into the ECX register. That's been done already. So if we look at ECX, this is the size. It's 15 characters, it looks like. I guess Abraham Lincoln is 15 characters. Let's well, let's see what the stack pointer. The stack pointer is this. All right, I'm gonna copy this. Okay, and the stack is gonna grow down, right? So I'm gonna copy this, copy, and I'm gonna pull up another memory, memory 2, and right here I'm gonna paste that stack. Was there like a 0x in front of that? Just to make sure. Enter. Okay, here's the stack, and it goes up. So I want to go down, I guess. All right, it's empty. Okay, it's gonna go. It's gonna on this. It's gonna look like it's gonna go up, but really it's going down in memory. All right, so let's execute this, and it should stop after the stack is all filled up. So let's continue. Now it's down here, and did the stack fill up? I don't know. Let me try to make this bigger. Oh yeah, look. ABRAHAMLINCOLN. It's as we pushed more letters in, it went backwards. It went up and down. This when you go up like this, it goes down in memory. And the reason there's these spaces in between, because we are loading in. We are pushing 32-bit words, double words, and it's just we're only using the lowest byte. So these characters, so that's why there's each character is actually taking up 4 bytes, which of course. So anyway, so that's that. So we see the A. And then let's look at the other memory. Okay, this is the other memory. Now when we execute again, it's going to pop out from the stack and write it back in. So we should see the reverse here, right here in the memory when we're done. Okay, so let's execute. Continue. Boom, now it's down here, and look. Abraham space Lincoln. That's pretty cool. So anyway, so let's continue, and it quits. All right, so that's how we can show. Let's go back to our slides. So we've shown how this reverse. We've actually executed this reverse string, and next we're gonna actually add some inputs where we input a string, and instead of reading it from the memory. Let's finish up these slides first, and then I'll go back and I will mess with. Okay, when we get to the Irvine library, because the Irvine library is what we need to use to call these Irvine functions, which will request data from the user and will display out message boxes. So let's continue this, and let's finish the slides here. Related instructions to the stack instructions are push FD and pop FD, and what this does is this pushes the flag register. the E flags register. So this pushes the flag, it's a D double word, and it pops it back into the flag registers. This push AD pushes all of the 32-bit general purpose registers onto the stack all at once. In order, at first it pushes the EAX, then the ECX. Oh, is this the order? Okay, EDX, EBX, ESB, SP, EBP. Anyway, in that order, and then so if you want to save the whole state of the microprocessor at once, save all the registers, and then do a bunch of stuff, and then you can pop them all back out again and return just like nothing ever happened. So those are convenient. That's convenient instructions. Push A and pop A just does it for 16-bit registers. So if you're just running in 16-bit mode or in real mode or whatever, you only need to use these, and of course it's half as much. D is double word. There's no D at the end of those two instructions. So here we're going to write a program that does the following: assigns integer values to these values, and then uses the push AD to push them all onto the stack, and then using a loop, pop each integer and display it on the screen. Okay, we will get back to this after we introduce ourselves to the Irvine library. I think these slides were written before when he had integrated the Irvine library earlier on in this chapter. In this chapter now, he saves it to the kind of the last section of the chapter. All right, so now we're going to talk about how you can define procedures, subroutines that is, and how you use them. And then after that, we'll get into linking the external library. Okay, so I'm going to close this video and come back and talk about this section. So let's do that, and I will see you soon.